Welcome back. Today I'd like to teach you how to evaluate a polynomial, and that I'll teach you how to do that both with and without a calculator. So a polynomial can be evaluated if you substitute a number in for the variable and then figure out what does that expression equal. This is essentially what calculators do. If you have a TI-82 or TI-83 or TI-84 calculator that's got variables and you type something in, it will evaluate it. That's what it does. And I'll show you how to do that in just a minute. I say that as a hint because well, it's what you can use your calculator for. I also tell you it as a warning. If you were to try to add or subtract or multiply polynomials by just typing them in your calculator, it's not going to do that correctly. It will evaluate it and just give you a single number back, which might not be what you want. So, anyway, here's the polynomial, and I just picked a couple of numbers here for x to use that we can evaluate it with. So, to evaluate something means to plug in the number for the variable. Substitute is the technical word for that. And so if we wanted to evaluate this when x is 0, that means everywhere I see an x, I'm going to plug in the number 0. So 0 to the 4th power, and 2 times 0 to the 3rd power, minus 5 times 0 to the 2nd power, plus 3 times 0, plus 5. What does that all equal? Well, 0 to the 4th power is just 0, and 0 to the 3rd power is 0, and 2 times 0 is 0. And, well, same thing happens here, and same thing happens here. In fact, evaluating when x is 0 is really easy, because any term that's got a variable in it is just 0. It cancels out. You can ignore it. The only number that you can't ignore is this 5, which doesn't have a times 0 by it at all. And so 0 plus 0 plus 0 plus 0 plus 5 equals 0. So I'm going to start a table here. If I plug in a 0 for x, then I get out a 5. That's what evaluating for 0 means. Now we'll do the same thing, but we will plug in a 1 and see what happens. If we plug in a 1 for x, 1 to the 4th power is just a 1. And if we plug in a 1 for x here, 1 to the 3rd power is a 1 times 2 is just 2. And when I plug in a 1 here, 1 squared is 1 times minus 5 is minus 5. And when I plug in a 1 here, 3 times 1 is just 3. And here there's no 1 to plug in. It's just plus 5. And, well, plugging in a 1 is pretty easy to do too. Basically, if you look here, it's just what is the coefficients of each of these. That's what you end up getting when you plug in a 1. So to evaluate this by plugging in 1, you can essentially kind of do a shortcut and just do 1 plus 2 minus 5 plus 3 and plus 5. If you can do that all in your head, then you can do this evaluating just your head. 1 plus 2 is 3. 3 minus 5 is negative 2. Negative 2 plus 3 is 1. And 1 plus 5 is an 8. So I think I did that right. Let me check again. I'm a little worried about that. Let me think here. 5 and negative 5, those cancel themselves out. And then 1 plus 2 plus 3 is a 6. I got an 8 last time. I got a 6 this time. Let's maybe get out the calculator and calculate it with the calculator and see which is right. So to evaluate something with a calculator, what you should do first is take the number that you want to plug in for the variable and store it as that variable. You can do that by just pressing the number 1. Oops, wrong button, sorry. So 1, and then we will store that, the little STO button stands for store, into the variable x. So you can hit either alpha store to get the x, or this button, xt theta n, puts an x on the screen, which is a little easier. So if you do that and press enter, now 1 is stored in x. And so if I did x to the 4th power, that'll be 1 times 1 times 1 times 1. It'll give me a 1 back. And if I were to type this entire expression, so x raised to the 4th plus 2, oops, forgot the plus, plus 2x raised to the 3rd, and then minus 5x squared, and plus 3x, and plus 5, we'll see if either 6 or 8 is the right answer. 6. So I must have made a mistake the first time. So now let me show you kind of a shortcut I like to do. X and then finding the exponent for and all that sort of stuff is kind of tedious. What I often will do is just do x times x times x times x. That's x to the 4th. Because it's easy for me just to hit the button 3 times. That's 2x cubed minus 5x squared plus 3x plus 5. This will give me the same thing. It should still give me a 6. So, and if we wanted to evaluate this now with a 2 instead of a 10, that's easy enough to do. We'll type 2 and store that in for the variable x. And we can either retype that whole thing, or you can hit second enter and second enter again, and it will cycle back through the last couple things that you've typed. And now I can hit enter. And apparently when you plug in a 2 for x, it evaluates out to a 23. Just to show you what that is. Let me erase this a minute. If I plug in a 2, 2 to the 4th power is 2 times 2 times 2 times 2, that's 16. 2 to the 3rd power is 8, and 2 times 8 is also 16. 2 to the 2nd power is 4, 2 times 2, 4. 4 times 5 is 20, and that's being subtracted, so minus 20. 3 times 2 is 6, and then 5. If I were to add these together, 16 and 16 is 32. Minus 20 is 12. 12 plus 6 is 18. And 18 plus 5 is 23, just what the calculator said. And last but not least, evaluate this with a 10. I want to do 10 just to show you that 10 is kind of an easy one to do as well. Like 0 and 1, 10 has kind of a nice trick to it. So if we plug in a 10 for x, 10 to the 4th power is just 10 times 10 times 10 times 10. That is a 1 with 4 zeros behind it. And 10 to the 3rd power is 3 zeros. When you do 2 times 10 to the 3rd power, that's a 2 and 3 zeros. And then minus 500. So I'm going to actually leave that out a little bit for a reason why I'll show you in a second. 3 times 10 is just 30. And then 5 just drops down. It's extremely easy to add these numbers. It's just 1, 2. There was a 0 in the hundreds column. 35. But I do still have that minus 500 to deal with. And I can subtract this in my head. 12,035 minus 500 becomes 11,535. And let's confirm that with the calculator quick. Remember, we'll store 10 in for x. Oops, we got the store button. Store into x. And then I'll hit second enter twice to go back through and see what that answer was again. And it does indeed give me 11,535. Now, why do we bother evaluating things at all? What's the point? Well, one reason to evaluate polynomials might be to check our work when we're adding or subtracting, or later when we learn how to multiply or divide or factor things. You can check your work by evaluating things. Let's do the subtraction quick, and then we'll check it by evaluating different things. So this is 3x squared, and then there's a minus x squared term here. So a positive 3 and a minus 1, I think that becomes 2x squared. And then here is a 2x, and there's no x term anywhere here, so that's just going to transfer over. And then here I've got a 5 and a 3, and when I add those together, I'll get an 8. And now I can check my work, see if this is true, by plugging in a number. And if you plug in a number in this first expression, what I call the before, and then you plug that same number into this expression, what I call the after, I need to get the same thing on both sides if this is really equal. So it doesn't matter what number you choose, it should always be equal. So I'm going to choose 10, just because it was the last thing we were thinking about. And this first expression, 300 plus 20 plus 5, that's 325. And this is 100 plus 3, so 103. And if I subtract those, 325 minus 103, that should give me 122. No, 222, excuse me. Over here, if I plug in a 10, this is 220 and 8, 228. I see that 222 and 228 are not equal. They should be equal. It says they were equal, but they're not. So either I checked my work wrong, or I made a mistake in the original problem. Since I got the calculator, I'll quickly check it and make sure that I didn't just evaluate something wrong. So 300 plus, oops, I always forget that plus sign, plus 2x plus 5, and then, oops, I should put parentheses around it to be pretty specific. So insert, second insert, a parenthesis. And then at the end, I will subtract, and then in parentheses write x squared plus 3. And if I evaluate that, I think 10 is still plugged in for x. It is. So I get 222. And then I'll check my answer. I said that should be 2x squared plus 2x plus 8. And if I check that, I do indeed get 228, which means my mistake is somewhere in this work. This is not a true statement. 2x squared plus 2x plus 8 must not be right. So let's see if we can figure out what happened. So let's see, the 3x, I think I might have made a mistake because of the minus sign. I probably should be a little more careful and distribute this minus sign to both sides, which means it's a negative x squared and a negative 3. In fact, I think that's what I did wrong. 5 and negative 3 should not be 8. 5 and negative 3 should probably be 2. Then I get 222, like I should there. That's probably what happened. So, see, that's how checking your work can be done. Now, if I had tried it with a different number, like 2 or 1 or 0 or some other random number that you might happen to have stored in your x coordinate, no matter what, it should always equal. And so if it doesn't equal, you know you made a mistake somewhere. So it should be equal for every x. Really, the best way to check your work is not to try a single number like this, because it's possible to actually get a false positive where the numbers match but it's not actually equal. That can happen a lot if you try checking your work with the number 0. But it should be equal for every number of x, and the quickest way to check every number for x is actually to make a graph. A graph is the quickest way of checking every value. And so let me show you what that would look like on a calculator quickly. And we can sketch that graph here. Here's that same problem. I think we said the answer was 2x squared plus 2x plus 2, right? And let's see what happens if we tried to graph the before and the after. I'll put both of those in my y equals screen and see what we get. So if you go to y equals, let me clear out, oh, apparently it was already in there. We'll put in the question, so 3x squared, and then plus 2x plus 5, and a close parenthesis, and then minus, open parenthesis, x squared plus 3, and a close parenthesis. And then I'll go down to y2 equals and type in what we think the answer is, 2x squared plus 2x, oops, forgot the plus again, plus 2x plus 2. And one thing I like to do is to make the second equation dark, and you can do that if you go over with your arrows keys and hit enter. That will make the second line darker. And since I have a graph here, I probably ought to match the window settings so that I can draw a picture of it accurately. That's under Window. And the smallest x number that I see is a -5. So I'll put a -5. Oops, I put -5. I should do a -5. The negative symbol is this button down here as opposed to the minus sign. The biggest x value is 5, and the scale is going by 1, so that works. And then the smallest y value I see is -1. The biggest y value I see is 10, and those scales are going up by 1. So that's the correct scale here. I can hit graph now, and here that's our question, our before, and our answer. Notice it's right on top. It's the same picture, and since they match, I know I did it right. So anyhow, that's how you can check your work, by evaluating, and also a little bit of a preview of graphing, something that we'll talk about in more detail in a few weeks. So thanks for listening. Come back again tomorrow to figure out how to multiply polynomials.